Bold title. My name is Rybalchenko. I am from the Department of Physics, and the title of my presentation is Solving World Problems, One Battery at a Time. With recent events that are happening around the world, in Europe, in Ukraine, and the sanctions that are being placed, a lot of countries are reflecting on their dependency on others. Ireland needs to become energy independent, but it also needs to meet the Paris Agreement requirements on climate change. We've been installing a load of wind turbines and wind farms in Ireland, which is good stuff, but it doesn't really solve the problem perfectly. Wind is unreliable, unstable, and moody. A little bit like me when I'm hungry. When wind is too low, there isn't enough energy to sustain the grid, and when wind is too high, we have all of this excess energy that has been wasted. So, what do? A battery. A large-scale grid battery integrated with the Irish electric grid will store all of this excess energy during high winds and feed it back to the electric grid during low winds and higher demands. A perfect battery for this would be a flow battery. My research group in particular studies one called a vanadium flow battery. Vanadium is an element. It comes in a crystal blue powder form and is diluted into an electrolyte using acid and water. This is a vanadium cell that I built in the lab, and it undergoes charging and discharging cycles, and it changes color from blue to green, yellow, purple, even a brick red color. It really is a sight to see. When you compare vanadium flow batteries to that of lithium-ion batteries, for example, it scales extremely well with capacity, size, and finance. It is recyclable and has a longer lifetime. It also has a lot less ethical issues associated with the materials to actually build that kind of battery. It has a very fast response time. It means it can respond to the grid very quickly in a short amount of time with the correct power output. It is also extremely safe because it isn't flammable or explosive. The New York State Fire Department named it the safest battery to have in your apartment blocks. So I've said all of these amazing things about vanadium flow batteries. What am I actually doing for my PhD? Well, my interdisciplinary research revolves around three areas: electrochemistry, physics, and programming. I do laboratory experiments, I do data analysis, and simulations and coding. I've been in contact with EirGrid, and they've given me data on the Irish electric grid for the past couple of years. Using this data, I was actually able to simulate a vanadium flow battery for the Irish grid with the correct energy and power input and output. I've been able to do self-discharge experiments in the lab so I can prolong its lifetime and increase its capacity. I do comparative experiments on different materials so that I can get a better performing battery. All of these areas allow this battery to be the future of Irish green energy. We are one step closer to having an energy independent Ireland and a 100% green grid. Grabh míle maith agat.